There are hundreds of thousands, if not millions, if not billions of NPM JavaScript packages. And in today's video, I want to talk about a really interesting injection attack that I got to witness live back in 2018. Now, this was an issue opened by Falling Snow on November 20th, 2018 on the event streams NPM package. Now, what the event streams package would do is essentially a toolkit for making streams and event streaming easier in Node. Simple enough, easy enough. And this issue was opened by this user who saw a commit from an unrecognized contributor with some very, very curious looking code, as we can see here. So let's dive into this code and pick it apart a bit and see if we can figure out what is going on. So here I have a temporary folder with the malicious code and a bit of a disclaimer. Do not run this code. Do not run or copy paste any code for that matter that you may believe to be malicious. Only trust sources that you know to be reputable and that you have trusted in the past. So without further ado, let's go. Now I called this bad.js. And the original finder of this code with this commit pretty much took it for what it was. It's a bit of a spaghetti mess. And I think they commented out this bottom section to make sure that in case you did run it, it wouldn't actually run the malicious parts. Now, really the first thing that should stick out to anyone is this string right here. It's just called n. How far does this baby go? Okay, so this is a whole string of something. Now, the next interesting thing I see here is this require crypto, create decipher, AES256, and npm package description. So npm package description looks to be some description here. Now, there's really great explanations in the actual issue for itself, but I'll explain how people were able to figure out what this npm package description was. So essentially, as we can see on line 24 right here, npm package description, that variable, is getting used to decipher the actual injected string here. So we can see that the decipher variable is update, and it's actually taking it from hex to UTF-8. So this decoded right here, this is going to be the actual plain text from this large string here. So to kind of rewind the wheel a little bit, we have decipher is being used to create our plain text, and decipher is getting generated from this npm package description, which is a string here. This is not the correct key, by the way. This is just something that was left in by the attacker. And n is right here. This is just our injected code, essentially, that we can see. Okay, so we inevitably get decoded right here, and that should just be our plain text. For some reason, they print this out. Looks like, I don't know why this is here. I wonder if that was left in by the actual finder of this issue. And decoded.final UTF-8, so that's where we're actually getting the final part of that. I'm not sure what that final method does, but I'm guessing decoded, that's just getting added on. And then new module constructor. Okay, I see what's happening. And then I'm guessing decoded. Yeah, so we can see decoded here is compiling a new module, a new npm module. So yeah, this is a injection attack for whatever code is getting decoded in there. So now, one of the biggest mysteries that first needs to be solved is to figure out what the injected code is, and to get that in plain text, we need to actually see what this npm package description variable is, because that's the key for actually decoding it back into plain text. Now, this variable, this could have been anything like secret key or something, and it would have been a lot harder to figure out exactly what that was. But instead, they named it npm package description. So that really tells us something about the key itself. Instead of it being any possible random string, which really could have been literally anything, literally an infinite number of options, we can essentially narrow it down to just the npm package descriptions. So somebody out there in the wild was able to find some list of npm package descriptions. And while this list of npm descriptions is extremely large. It had to be as big as every NPM package ever published. It's a lot smaller than every string ever possible, which essentially would be an infinite possibility of strings. That makes brute forcing a solution much, much easier. So now we can brute force using this list. And using this list, the users went through every single possible description and put it into this npm package description variable. They were then able to find the plain text code from this injected encrypted string. The unencrypted code that's being injected into this package came in 2 payloads. Now, the first payload we can look at, and essentially all this is doing is exporting a new module. It requires the file system module here, and then we can also see that it's doing a file write sync. Now, this is really important because the next payload needs access to the file system in order for the attack to run. So let's look at the next payload here. And this one is a little bit more lengthy. We can see it spans quite a bit of code, but there's a few really key things to notice here. First, it has a public key. Now, this public key gets used in this function R right here, which essentially sends something to an address out into the ether or wherever with that public key. So we can see that the public key is getting used right here. So then my next question is, okay, if the public key is getting used there, then where does this R function get used? So there's the definition of it. I'm going to go next, and I can see right here that it's getting used. It's sending something as stringify JSON. Let's go to the beginning of this, and I can see T-balance. Look at that. Bitcoin, and that looks like Bitcoin Cash. So what's happening here in this chunk is I see that we're iterating over something, and it's probably looking for something within whatever file system that this is running in to then send away your Bitcoin, send away your Bitcoin Cash. So once this code was essentially decrypted, we can pretty quickly determine what it's doing, what its general target is, and then how we could maybe prevent against it. Now, thankfully, this was a targeted attack on just a few wallets that had specific vulnerabilities, but these could have been wallets running in any number of NPM packages or modules or programs or whatever. Now, I want to zoom out just a little bit on the actual issue and the community and sort of the buzz that this generated. As you can see, it had 1,000 upvotes. It was blowing up all over Hacker News and the internet, and it had hundreds and hundreds and hundreds of comments and people talking about it and what was going on. Now, the biggest thing to note is that one user was given push access to this repository. Now, this user is gone. This was 2018 years ago, but basically the main maintainer gave access to this person who didn't really have a commit history, didn't really have a presence in the community of this project. They basically emailed the maintainer, this person here, and said, hey, I would like to be involved in the project. Can you give me maintainer push rights? And this person said, sure, fine. And boom, before you know it, they injected their specially made package, this flat map stream, into the project, which then contained this code chunk that then had its injected code to steal Bitcoins from a targeted wallet. And really, in my opinion, this reveals something really interesting about how open source works and how people get involved and just the blind trust that you and I give to all the software that we run as software developers every day. Now, I think NPM is especially guilty of this, especially since it's not hard for anybody just to publish a package out there into the wild, and those things create this crazy web of dependencies. You know, this thing depending on this thing, depending on that thing, and before you know it, you have a whole supply chain attack on your hands. People really, really railed into this guy for allowing access for this person and allowing them to basically get access to the whole repo. Here it is. I remember reading this. He emailed me and said he wanted to maintain the module, so I gave it to him. I don't get anything for maintaining this module, and I don't even use it anymore and haven't for years. This was a totally bespoke project, but it was a really important one because it was used by so many other projects around the NPM ecosphere. So that really makes my first point with this whole thing is you got to trust the software that you rely on. And if possible, you have to be involved. Be involved in the open source projects that you use and that you use in your projects. That way there's a sphere of trust around the open source projects that you use, that you're involved in, and you can start to see the cracks or the things that just don't make sense and be on the front edge of being able to catch something like this. Next, I want to talk about how you might be able to catch something like this actually. Seeing something like this, some random long string, should immediately tip you off that something is not right. Don't just blindly believe like, oh, this person's committing this, it's probably fine. They've maybe even committed to this repo before, or they're adding a package. I don't recognize that package. What is it? It's okay to ask questions, and it's okay to poke around open source code, because the moment you see something like this should immediately tip you off to something really, really weird going on. The next thing I hope you learn from this is that there's a reason that hackers like to obfuscate their code. There's a reason this person named their function I. There's a reason they named it R and L. Those are really, really easy function names to just pass over with your eyes. I mean, I did it like several times here. I was trying to like pick this thing apart and just kept being like, wait, what am I trying to look at? I didn't install code completion on this because I didn't want to have things running automatically just to be extra safe. But I don't think you should either. So that makes it another way that you can easily be attacked when trying to pick something apart. So, one, be very careful when picking something like this apart, but also, notice these things. Notice that there's a reason that they're calling something just R or I or some initials. People got really lucky. They got really lucky when they were looking at this initially, because if npm package description hadn't actually been an npm package description, then things would have just been really, really bad. It would have taken all of time to actually figure out what this npm package description was. There would have been no way that it could have been brute forced like it was. But thankfully, eventually, somebody found a list of all the package descriptions, brute forced it with that list, and found the plain text code using a brute force method. And finally, I think you got to look for the keywords and the things that really would be almost impossible to hide. Like the moment I see something like BTC or .coin or Bitcore wallet client, then I can make a pretty good generalization about what this attack does, who it's attacking, and who really might be at risk. It was absolutely wild to see this unfolding live before my eyes. The company I worked at was using a package that used the package of event stream. So somehow in the web of dependencies, my company was potentially at risk. And it went like days before people really were able to pick it apart and figure out what was going on. For a little while, people thought like, oh my gosh, is this like one of the biggest vulnerabilities we've ever seen? But it was a very, very targeted attack against a very specific wallet with very specific vulnerabilities on it. So it could have been a lot worse. But I witnessed a huge supply chain attack that probably affected millions and millions of users and developers happening live. So I hope you found this useful. I hope it gives you an idea of maybe some of the things to look out for. And please, 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 please be involved in the open source communities, that you use their software and that you partake in the community to catch things like this. Because without developers like you or me or the good guys, then we're going to be supply chain attack after supply chain attack. And before you know it, we just won't be able to trust open source software anymore. So I'm John. This was John Codes. And I hope you enjoyed this video. Please like, comment, subscribe. It really helps the channel out. And thank you so much to my current subscribers. I will catch you guys next time. Peace.